So then I will take over this now for the next 30 minutes here. And as Jenny already said, I will speak today about two topics which are one of my personal hobbies also at work. And one is to speak about the assembly plant of the future, which is very relevant for you as an assembly company, but also very relevant for your customers to understand what is the vision where we actually go through in the future. And also, secondly, I will speak about digitalization in customer engagement, which is a very hot topic right now because of all the corona, because of all the topics when you cannot go to customers anymore. The buying journey gets so complicated. So I will show you how we in Atlas Copco Nordics changed our organization and also changed our approach to engage with customers. But I will get just to the topic. And before I go to the details, just a small introduction who I am. I'm the business line manager for Nordics in Atlas Copco. I'm responsible for the whole motor vehicle industry at the Nordics. And that is, of course, the big customers like Volvo Cars, Volvo Group and Scania. But it's also for the tier ones, which are supplying to them, like IAC, like Haldex, and so on. I have a sales force, which I'm directing here in the Nordics, but I also have a project office to realize all the projects which we win at our customers. We are quite big as a company in this market here, in this niche of assembly. And on my big accounts, I have a market share of 90%. So the growth is quite difficult in my market here if you're already at 90%. So I think we have to find some new customers in the Nordics here. And at the same time, I'm also global key account manager for the Volvos, like Volvo Group and Volvo Cars. Before I took these positions, just as a reference, I was a global marketing manager in assembly, where also my passion for marketing comes from. And before this, I was a global key account manager in Germany, taking care for BMW and MAN, getting to this blood and sweat school in sales with the German automotive industry, and learned a lot during this time as well. And before, I had a lot of different positions at Bosch around the world. I was working in Germany, in China, US, you name it. It's a lot of different positions I took in, and I have a lot of history in purchasing as well, and also in operations. But I think since the last 6 years, I'm really home in sales and marketing. Let's come to the trends, which we actually see to set a little bit the stage. So the major market trends, as I think you also know, they accelerate. The electrification is a really hot topic in the markets, especially in Sweden. Automatization is a big topic in the assembly processes. There's much more robots there than we had several years ago. And the biggest trend I always see is Industri 4.0, which means we have a lot of data gain in the assembly process. We have optimizations out of this data and a lot of connectivity between tools, infrastructure, and so on, which I will show you a little bit later on. Our key accounts in the Nordics, they fully restarted their production after Corona. You have known this most likely, that Volvo was down, Scania was down, but they're all back. They all have the order books full, but they are a little bit still unsafe about the future, but they are running all on full pace. The restructuring in the markets, they took place. For example, Volvo Group sold UD trucks to Isuzu. We have new foundations coming up with powertrain in Schöfte and so on. So the restructuring in the big companies are done, and they are all looking to the bright future now. The daily business, as we see it, it picks up again. 2020 was nearly dead. There was no daily business at all, only projects. And now in 2021, this is back. So the customers invest again. But the big focus from the customers right now is on critical investments and activities. And that's the major trends which I was speaking about, acceleration of electrification, automatization, and Industry 4.0. There are the big budgets at the customers, and there you have to sell to get your money. What we still have a lot, being for me in sales and marketing, is we have a big challenge to be at the customer for sales and marketing. They only want to see us currently for critical things like service or installations, but they don't want to listen to us if we want to pitch a new product or if we want to sell something there. And what we also see in the market is there's a lot of less bigger investments, for example, in powertrain, which was the natural home of Atlas Copco. So we were really strong here building engines and so on, but there's no more big engine lines coming up because the trend to electrification is coming. So we have to transfer also our whole sales from powertrain combustion engines to electrification, and we also have to transfer this farming attitude which we have in sales, because we were so big, we got automatically everything, to a hunting mentality, being at the customer again, telling the customer what to change and talking them into new business. So on a higher scale, what kind of customer challenges are there? I mean, what we see all the time is that the product mix at the customer is increasing. They are building so many different models at the same line nowadays. The system complexity is increasing a lot at the customer. So what they do in one station is not the same as they have done several years ago. So they have a lot of different operations there with a lot of different requirements. So it's really difficult for a worker to assemble something nowadays in the car manufacturing. The human interaction becomes very critical, so that the people must really get feedback of what they are doing at an engine or a chassis, and that is very important, that we have like screens everywhere, that we have immediate feedback with lights, that the people really know that what they did is the right thing. And the last trend, of course, is sustainability. So what we always have to do is we have to reduce footprint, we have to reduce energy, we have to reduce rework things, so to really think about the resources, because all our big customers, they have it really high in the values to be more sustainable, and it becomes a value to win business. If you are not sustainable, that will be a veto from sustainability officers in the future. So therefore you have to really take care that you are also green on this point. And now I want to try a nice presentation on you, which is really interactive. We built this especially out of the necessity to be digital connected to customers. And this presentation is actually called the assembly plant of the future. And in this presentation, I can actually build together with an audience from the current setup of assembly to a future setup. And don't be scared. I mean, we are not speaking about assembly processes of tomorrow. We are speaking about the assembly processes of 5 to 10 years from now on. Because I always say we have to have a vision to develop the products for today, which are relevant in 5 to 10 years, because it takes always so much time to develop this. So now let's move into the factory of the future. Actually, today we start with the factory of today. And here you can see a normal setup of how you produce an engine today. So you can see there's a guy, a blue collar worker, which has an engine in front of him. He has a lot of instructions on the left side. He has parts on behind him, and he has like something to assemble on the left side also in front of him, which is an alternator in this case. And you can also see that's not only one alternator, he has 4 there. So that's actually already a quite clean setup, which you will not find at a lot of customers, but it's, I think, somehow the setup of today. So what you actually can see there, which is very easy to change if you want to have a future setup. I mean, you can take all this, this paper stuff and put it actually on a screen. I mean, that's the first thing you do. Some years ago, you had all these boards in the production, which were paper boards. Now you have screens. But on the screen, you actually put all the production processes and instructions in a digital form on the screen, which you can actually show on an easy way to the worker what to do on the engine. And if you speak about what to do on the engine, then I want to show you at first what we really want to reach in the assembly process. And what we want to reach in the assembly process is we want to work on the biggest root causes of mistakes, which are always man, machine, material, method, medium, and measure. And how do we actually do this? What we want to control in an assembly process, we want to compare the actual assembly process versus the target. And then I mean, everything was done with the right method, with the right people, and so on. And when we speak about, for example, man, then it's very important that we control that the people which have the right specification and also the right training to work on the assembly process. So we have to control who does it. What else we have to control? We have to control which tool does this worker actually take. If we have a complex assembly process, then this worker has like 5, 6, 7, 8, 9, 10, 15 tools lying around there, and we have to make sure that he takes the right thing. The next thing we have to take care that in an assembly process where you have to assemble like 5, 6, 10 different alternators to the engine, that we take the right one to assemble it to the engine. So we have to control the material which goes there. The next thing we have to control is the method. So I mean, if we tighten something on an alternator, there's torque values which have to be done in the right way, and this has to be controlled. The next thing which we have to control is where do we actually do this tightening. So I mean, do we have the right engine in the assembly, or do we have another engine in the assembly? So that must really match. And this we all put actually on the screen as an instruction, but then we still have a lag. I mean, how do we get the control from the screen and also from the brain, which we have in the instructions, to the assembly process? I mean, there's only one way. You have to build an integrated system, which everything reporting to this overlaying system. And that means you have to put like a controller into this assembly process, and you have to connect each and every tool the people take for this assembly process to this ecosystem. That it is an ecosystem which is enabling only the right tool to work in the right sequence with the right torque values on the right joints on the right workpiece. So everything must be 100% synced with each other. We can connect, for example, scanners in the future, but make sure that we have the right engine. You don't have to read the label of the engine. You scan the engine, and then automatically all the instructions are set for the assembly process. You can also scan the materials which you put into the engine, that you also know that you take the right materials which you put into the engine. And later on, you can also then see if you have a problem with some screws, which screws you have actually in which engine. So if you have a rework or a recall, you can actually say which engines are affected. Another thing is, of course, you have to make it much more visible what you actually take for materials to put into the engine, also to help the operator in a complex assembly process where we have like 15 different screws you could take, to always take the right ones. And of course, there are, in the end, even systems possible to control that you are making the right tightening at the right place, which having an accuracy on the bolt level, so that the worker is not able to tighten the wrong joint, because the tool is only enabled when he's at the right place. Finally, you can even add laser systems in this assembly process, which shows you where to go, so which tightening you actually have to do. And I always say, as a German, you have to make it that clear that you can put a monkey there. I mean, that nothing can go wrong. That's the beginning, that's the setup, that's how one station works. But of course, you want to have in the future a scalable solution where you have a lot of different stations which have this complete transparency and production flow. But the next step, which is also, of course, Industry 4.0 approach, is you have to connect the stations. And why do you actually want to connect them? I will show you in a later stage. But you want to connect them, you want to centrally configure them, so you don't want to run to each station. You want to have the quality and the manufacturing engineers sitting in his lab and setting up the stations from there. And the next thing you want to do, you want to define stations which gain the knowledge from other stations to actually optimize the work in the stations. And this I will show you on the next slide here. And just look at the 3 stations. So the very left station you have here is called a rework station. And in the middle, on the right side, you have stations where you actually do some assembly processes at the engine. And I want to show you how in Industry 4.0 the data flow will be set up. Customers will have the complete control about what to be done, and they will actually send these protocols to virtual machines where on a server, this is all distributed to the different stations. And they will actually distribute not only one tightening, they will distribute a complete shift. So that even if you break the connections to the servers, you can still produce something in your manufacturing. For example, now the guy in the middle and on the right side, they scan the motors. They know exactly what to do by this scanning. They will enable their tools. They will do a tightening. The middle guy, you can see the information is running from the tightening to the left to the rework station. It shows okay. And also the information will go to the server, will be actually stored for the future that you can prove that this tightening was done correctly. Now the right guy does the tightening. Maybe he has a Monday morning sickness or something, so something's going wrong there. It's a tightening which is not okay. So this information goes to the rework station. It also goes to the server. It will be archived. Now the guy on the rework station gets this engine which has the wrong tightening. He scans the engine, and with the scanning he gets all the information of all the processes done before. So the screen shows him that there are some non-okay tightenings, and in this screen he also gets an instruction how to repair this. He does the repair. He's one of the best workers we have in the plant. You can see it was successfully. And this information goes also to the server and also is stored for this engine, that you can prove that you have done a rework. So the loop is really closed. And this is something a lot of companies today still don't have. They do a quite okay production setup, but if they have rework, they cannot prove that in the rework they did everything perfectly, because rework is a very complex station. We have a lot of different assembly processes, and there you don't have a data flow. And in the end of the shift, you send the data to the customer, and you actually handshake with them and say, okay, this many engines has been produced, this many tightenings have been done, all these tightenings are perfectly done, rework was done, you can send them out, and you can prove to your final customers that all the engines you produced are absolutely fine. Our customers not only demand the system from us in the future, but they also will demand that we service these systems, because none of our customers, and also not you, are experts in IT infrastructure. So we need actually service offers as a supplier to our customers, which actually helps the customer for installation setup, for process configuration, for functional tests, for operational training, and also for the configuration backup. Because what the customer really wants to do in their production, they want to have a first time right. So when everything is set up, everything should work. They want to have a time and cost saving with the installations, and they want to have actually a trouble-free and efficient start of the productions. And they also want to have the minimized risk of any production quality failure. And therefore, I mean, you in sales, we in sales, we have to offer different scalable service offers to customers. And for example, for our products, we always sell them, our customers, something like a base package, which is a remote support, which is a setup of the systems. You can also sell them more advanced systems, which is like debugging support, remote application support. And also in the end, when we have like customers like Volvo, which have like a really high pace in production where every minute counts, we even offer them on-site support for our systems and everything to get everything up and running and keep it up and running. And if you really scale this up in the end, then we actually have the target to have a complete factory with all production steps completely digitalized, connected, and also to be able to configure them centralized and use the data which you have in each station to optimize the other stations. Because, I mean, data is king, and this is what we actually call in Atlas Copco the smart connected assembly. That was so far a short presentation about what Atlas Copco thinks the production of the future will look like. It's not like, as I said, next year, but this is something where the trend in the industry, especially in the motor vehicle industry, will move to, which is also your customers at Scania and so on. I mean, they will move to this setups in the next years.